Hey guys, welcome back to the channel. In this video, we are going to understand the nature of heat and work. Now before moving on to the actual topic, I would like to explain you all some basic concept of geometry because that is going to help us later in this video. Okay, so let us consider I have a cuboid and I want to find out the volume of this cuboid. Now we all know to find out the volume of this cuboid, the formula is simple: length into breadth into height. Am I right? But assuming that I do not know the formula, so how I can find out the volume? So what I will do is that first I will find out the area of one face. So let's say I first found out the area of this face and let's say it comes out to be A. So I know now that the area of this face is A. And let's say that the perpendicular distance or perpendicular length is L. So now I know the area of one face and I also know the length of the cuboid. Now if I want to find out the volume, then it becomes really easy for me. So volume is nothing but simply area into the length. So this is how you can find out the volume of any cuboid. Similarly, if I want to find out the volume of a cylinder, so how can I find out? First of all, I will find out the area of one circular face. So let's say that the area of this circular face comes out to be A. And let's say that the length of this cylinder is L. Now I can easily find out the volume of this cylinder. It is simply A into L. That is nothing but area into length. So this is how you can find out the volume of any cylinder or any cuboid. Okay. Now keeping this concept in mind, let us move on to the main topics, that is nothing but work. So now up till now what we know about work is that suppose if there is a block and if we apply a force on this block, then what is going to happen? The block is obviously going to move in a rightwards direction. So let's say that the block now reaches over here. So can I say that the block has traveled a distance S over here? Because we have applied a force, therefore the block has traveled a distance S. Am I right? Now I can easily find out the work. The formula for work is nothing but force into displacement. So this is how I can easily find out the work. But guys, this concept is used only in mechanics. When we want to study the thermodynamic work, the concept gets a bit different. Okay, so in your syllabus only pressure volume work is given, okay, which is also known as the moving boundary work. Only that type of work is given in a syllabus. So we will be studying only pressure volume work and we will not be complicating much. Okay, so let us understand the pressure volume work in thermodynamics. So let us say that I have a cylinder and in this cylinder I have a gas. Now I have enclosed this gas with the help of this piston. This blue color which you can see is nothing but a piston. Now we obviously know that this gas is going to exert some pressure on this piston. So obviously this gas is going to exert pressure in the upward direction. So let's say that the pressure exerted by this gas is represented as P of gas. Now similarly, the surrounding is also going to exert an external pressure on this piston in the downward direction. Am I right? For example, the atmospheric pressure is going to exert pressure in the downward direction. Am I right? Now guys, in this whole setup, let us consider the gas to be our system. So the gas here is going to be considered as our system. Now let us assume that the external pressure is greater than the pressure applied by the gas. Then what is going to happen over here? If the external pressure is greater, then obviously this piston is going to move downwards. Am I right? This piston is going to move downwards. But guys, when this piston moves downwards, can I say that the volume occupied by the gas is going to decrease? When the piston moves downwards, the volume occupied by the gas is going to decrease. and if the volume decreases, we all know the pressure is going to increase. So as you decrease the volume and as the piston moves downwards, the pressure of the gas is going to increase. So initially the external pressure is greater than the pressure of the gas, and therefore initially our piston was at this position, but now it will move some distance downwards, and at this point, at this stage, what is going to happen is that the external pressure will become equal to the pressure exerted by the gas. So the gas is exerting pressure in the upward direction and the external pressure is in the downward direction. And since both of them are equal in magnitude, therefore this piston will not move. Am I right? Now guys, let us say that this piston has moved s distance downwards, and let us say that the area of this piston is A. Now you can clearly see over here that the volume of the gas has decreased. In other words, since gas is our system, can I say that the volume of the system has decreased? So you can clearly see over here that some work is being done. Now I want to find out the value of the work done. So I know only one formula for work. Work is nothing but force into displacement. Am I right? So let us name this equation to be 1 and keep it aside. Now in this equation, if you observe, we know the value of S. S is nothing but this displacement. But do you know what is force? We obviously do not know what is force. So let us find out the value of force. Okay. So how you can find out the value of force? By using the formula for pressure. We all know pressure is nothing but force upon area. And here as you can see, the piston is moving downwards. Therefore I am going to consider external pressure. You can either consider pressure of a gas, but that will be in opposite direction. And both of them are same in magnitude. The only difference is that they are opposite in direction. So I am going to consider external pressure is equals to force divided by the area, and this area is nothing but the area of this piston. Why I have considered the area of this piston? Because the pressure is applied on this piston. So you obviously have to consider the area of the piston. Now from this formula, if you look out, I can shift this A to the left hand side, and when I shift this A to the left hand side, what I will get is force is nothing but external pressure into the area of the piston. Now I can use this relation and substitute in the formula of work. So instead of F, now I can easily substitute external pressure into area over here. So now I will get the formula for work as external pressure into area into S. Now guys, carefully observe these two terms, area into S, that is nothing but distance. So recall what we have done in the start of the video. When you multiply area by a certain length, what do you get? We obviously get a volume. So over here guys, if you multiply this area by this length, then you will obviously find out the volume, this volume above the piston. Okay, above this piston, whichever volume is there, you can easily find out that volume. Okay, so let us name this volume to be VD, and instead of area into displacement, now let us write it as VD. Now I can write this VD in some another way as well. I can write this VD as initial volume minus the final volume. How? See, what is your initial volume? For initial volume, you have to consider the initial position of the piston, and all the volume below this initial position, see, this much amount of volume will become your initial volume. And what is the final volume? Final volume is nothing but the volume below the final position of the piston. So this is the final position of a piston, and the volume below this will become your final volume. So when you subtract final volume from the initial volume, you will be obviously left with this much amount of volume, which we have represented as VT over here. So I hope that this becomes clear for you. And since here we are taking the difference between the two volumes, therefore I can further on simplify this formula as work, which is represented by W, is nothing but the external pressure into change in volume. Clear with this? I hope these terms are clear for you. This Vd is nothing but the volume above this piston, this much amount of volume. Vi is nothing but the total volume. Vf is nothing but the final volume below the final piston position, this much of volume. And when you subtract this much volume from the total volume, you are left with this much amount of volume, that is nothing but Vd. Therefore, I can write it as initial volume minus the final volume. I hope you have understood this thing. Now further on moving, guys, now here for work you need to understand two conditions. So first condition is during compression. So during compression, which is happening over here, as you can see, the gas is getting compressed because the volume is decreasing over here. So during compression, what happens is that the initial volume will be more than the final volume. As you can see over here, initially the volume was greater and the final volume has now decreased. So can I say that the initial volume has become greater than the final volume, and hence the delta V value will be positive. See, this delta V value will be positive. Why? Because initial volume is some greater quantity and final volume is some less quantity. So when you subtract a lesser amount from a greater amount, you obviously get a positive value. For example, 5 minus 3 will obviously give you positive 2. Am I right? So therefore, since the value of delta V is positive, therefore the work will also be positive. Work will be denoted as a positive during the compression. Clear with this? And guys, during expansion, what happens is that the initial volume will be less than the final volume. During expansion, what happens is that the gas gets expanded, and when the gas gets expanded, the piston is going to move upwards, and when the piston moves upwards, the final volume will be greater than the initial volume. And since the final volume is greater, hence the delta V value will be negative in this case. Why delta V value will be negative? Because if you subtract greater final volume, that is nothing but greater amount. Let's say that it is 5, and if the initial volume was 3 and it has expanded to 5, from 3 to 5 it has expanded. So when you subtract 5 from 3, 3 minus 5 will obviously give you minus 2. So here the delta V value will be minus 2, and since the delta V value becomes minus 2, therefore the value of work will also be negative. Okay, so as you can see over here, the value of work will also be negative. So I hope that you have understood, at least got a basic idea about what is work in thermodynamics. This work is called as the pressure volume work, and it is also called as moving boundary work. Clear with this? To make this concept more clear, let us take some example. So let us take an example of 2H2O2, which was present in a liquid state, and after the reaction it gives out 2 moles of H2O, which is again present in a liquid state, and it gives out 1 mole of O2 gas. So let us consider a container, and we all know before the reaction in the container there is 2 moles of H2O2 liquid, and this is enclosed with the help of the piston. And after the reaction, what happens is that we get 2 moles of H2O, which is present in a liquid state, plus we get the extra 1 mole of gas, that is nothing but O2 gas. So as you can see over here, after the reaction the volume has increased, and since the volume has increased over here, this system will try to push the piston upwards, and can I say there is surrounding present over here? This system is trying to push the surrounding upwards with the help of the piston. So in this case, where the volume increases, where expansion is happening, can I say, guys, that the volume of the system is expanding and the work is done by the system on the surrounding? Why do I say this, that work is done by the system on the surrounding? Because as I mentioned earlier, this system is trying to push the surrounding in a upwards direction. Therefore we say that the work is done by the system on the surrounding, and in this case we have already said that the work done will be negative. Okay, so in this case the work done will be negative. Am I right? Now you can find this in some another approach as well. See, uh, we all can see over here that the initial volume is less than the final volume. See, this initial volume, okay, where it has gone. So this initial volume is less than the final volume. Am I right? So obviously Vi minus Vf will be a negative value. So delta V will be negative, and hence, oh here there is a glitch over here. Here it must be delta V. Delta V will be negative, and hence work done is also negative. So this is how we can either find out by Vi and Vf value, or we can easily find out by this statement as well. When the work is done by the system on the surrounding, the work done will be considered as the negative. Clear? Now moving on, let us consider another example. In this example, as you can see over here, 1 mole of NH3 plus 1 mole of HCl, and both of them are present in a gaseous state. They give us 1 mole of NH4Cl, which is present in a solid state. So as you can see over here, earlier the volume was greater, but now the volume has decreased. So over here, can I say, guys, that the work is done by the surrounding? See, this surrounding is trying to push the piston downwards. So can I say that the work is done by the surrounding on this system? Am I right? And here the compression is taking place, and since the compression is taking place, therefore our piston is going to move in a downward direction. Now guys, here you have to comment below whether the work done will be positive or negative in this case. I am giving you a hint. Here there is compression taking place, and here the work is done by the surrounding on the system. Okay, so you have to comment below in the comment section whether the work done will be positive or it will be negative. Now moving on, let us find out what is nature of heat. First of all, my simple question to you all, what is heat? And guys, let me tell you all one thing, that there is no definition of heat as such. We simply say that heat is form of energy. Now what is the meaning of this? See, when you play cricket, if you want to score runs, then you can score runs by taking a single, or you can score runs by hitting the ball for 4 runs or 6 runs. So can I say that 4 runs and 6 runs or even 1 runs are form of scoring runs? Okay, by either you hit a boundary or either you take a single, both of them are nothing but the form of scoring runs. Similarly, heat and work are nothing but the form of energy. Suppose if you want to give out energy, or suppose if you want to exchange energy, then we can exchange energy either in the form of a heat or either in the form of work. So heat is simply nothing but the form of heat is nothing but a form of energy, and if you want to exchange energy, you can do it either in the form of heat or either in the form of work. So let us consider, if this green color is our system and if this yellow color is our surrounding, and if you want to exchange energy with the surrounding, if the system wants to exchange energy with the surrounding, then it can do it either in the form of heat or either in the form of work. Now obviously there will be a doubt in your mind that when it will exchange energy in the form of heat and when it will do it in the form of work. So listen carefully now. If the surrounding is at the higher temperature, and system is at the lower temperature, then the surrounding will give energy to the system in the form of heat. I repeat myself again. If the surrounding is at the high temperature and if the system is at the low temperature, then the surrounding will give energy to the system in the form of heat. Clear? And vice versa. Okay. So if there is a temperature difference between the system and surrounding, then they will exchange energy in the form of heat. So whenever there is temperature difference, energy will be exchanged between both of them in the form of heat. Clear with this? Now, when what are the sign conventions of heat? So we consider heat to be positive when heat is absorbed by the system. So when the when the system takes heat from the surrounding, or when the system absorbs heat from the surrounding, then we assume the value of heat to be positive, and when the heat is released by the system, or we can say that when the system gives out heat to the surrounding, then we consider the value of heat to be negative. Clear with this? Now moving on, let us conclude everything together. So if this green color represents your system and if this yellow color represents your surrounding, and here if the system does work on the surrounding, then we consider it to be negative work. If the surrounding does work on the system, then we consider it to be the positive work. If the surrounding gives out energy to the system, or you can say the system absorbs heat, you can say that system absorbs heat from the surrounding, then we consider the heat to be positive. If the system gives out heat to the surrounding, then the value is considered to be negative. And these sign conventions are going to help you to solve the numericals. So guys, I hope that you have liked this video, and if you have liked this video, then please don't forget to subscribe to the channel and go check out my channel where I have uploaded physics and chemistry videos. They might be helpful for you all. Guys, thank you for watching this video. In the next video, we will see the expansion of work, or you can say the maximum work, how it is produced. Okay, so stay tuned for that video, and guys, thank you for watching this video.